No? Yes? Yes, excellent. I'd like to start by asking for another round of applause for the organisers, because yesterday was a disaster for them, so well done, everyone. Yeah. The number of emails that were flying back and forth, flights were cancelled and rearranged and re-cancelled, and yeah, absolute nightmare. So yeah, thanks for sorting it all out. And the poor driver who picked me up at the airport, I think I had to reschedule about 5 times. Anyway, welcome. Have you had a good day? Yes. Is this the first big Devoxx? No, this was last year, was it? So damn it, I thought it was going to be the first. That's a shame. Never mind. Okay, so yeah, I'm going to be talking about the magic of small things, or microservices 10 years on. It should be 11, really, because it was 2014 that Martin Fowler and myself published what became the definition, really, of microservices. So sorry about that, for a start. I don't think we recognized quite how much of an impact it was going to have. Initially, it was quite funny when we published it. The SOA community went absolutely just off the charts, scared about what it was going to do to enterprise service buses and the big industries that had been built up around SOA at the time. But then things gradually settled down. And so what I'd like to do today, it's a little bit self-indulgent. I'll tell you my story about why I got involved in the early days of this architectural style, and then I'll talk a bit about what's happened since. So I hope that's okay. So microservices 10 years on. Oh, I'm using the wrong clicker. That would help if I had the right one. Always have a spare, redundancy. You see, no, I'll tell you a funny story. So I was at Go To Chicago, and there was an amazing woman there called Dr. Anita Sengupta. She was the principal investigator for the Curiosity lander, the Mars Curiosity rover for NASA, right? And she did this fantastic talk about how they designed it and built it, and they got it to Mars. And I don't know if you remember, it was quite a few years ago, but they had this incredible mechanism where it went through the atmosphere, jettisoned the heat shield, and then there was like a spacecraft that sort of put retro rockets on, and then it hovered, and then it lowered the rover on cables, and then severed the cables and then flew off. It was an incredible feat of engineering, worked first time. And it was a room very much like this, full of software engineers, developers, techies, much like ourselves. And she asked for questions, and one of the questions was, so what do you do about redundancy? What do you do if a system fails? And she just doubled over laughing. Just started creasing up laughing. And she said, the thing is, you can't build redundancy in the spacecraft because redundancy is weight. And the heavier you make the thing, the more expensive it is in terms of the rocket that you have to put it on top of, the fuel you have to put in the rocket to escape the Earth's gravity well. She said, no, we use a little thing at NASA we like to call engineering. And all the software people went, oh, we can't solve it by auto-scaling another rover. Yeah, start another rover container, that'd be fine. Anyway, so redundancy, I've got redundant clickers. I should probably get on with this talk, I haven't started yet. Right, 4 minutes in, blimey. Okay, so this is stuff that was on my mind back then, my mind. So I joined Thoughtworks back in about 2005. At Thoughtworks at the time, we were very involved in things like big investment banks in London, big retailers building big distributed systems like till systems, EPOS systems. I was involved in trading systems in capital markets and equities and so on. So that was the sort of software we were sort of building. And we were in these very big enterprises, often rubbing up against the same problem over and over and over. And this is one of the things. Lots of stuff was hard to change, right? So we had these big software systems all interconnected, usually by some kind of ETL spaghetti. Sometimes if you were lucky, you had an enterprise service bus in the middle. My former colleague, Jim Weber, calls them egregious spaghetti boxes. And the reason he calls them that is because they're designed to make architecture diagrams look nice, right? Because you can have a nice diagram like this. You can see this with all the lines crossing here. And then you buy an ESB, you put the ESB in the middle, and all the lines are straight. And that looks great on the architecture diagram. Of course, inside the ESB, it's still all like this, like spaghetti, right? So you've not solved any of the problems. You've just spent 25 million euros on making your diagrams look pretty. But that's fine. So we had lots of stuff that was big and hard to change. Big monolithic systems, big monolithic databases. This is actually Thoughtworks in about 2010. They'd got the message about not getting a service bus, but instead they built something called a middleware database. So instead of having a service bus, they used a database to do the same job. I'm not sure if that's better or worse. I think it's probably worse. But this is sort of Thoughtworks, different colors, lots of different data smeared around the enterprise. Lots of the sort of tooling and software that was around that we were using was very big and very enterprisey. So you think about the sort of application servers in Java land that were available. It was things like WebSphere, JBoss. We were using things like ClearCase for version control. Obviously, we had, use your words, the GitHub guy or a GitHub person beforehand. That was a distant in the future. We had ClearCase. ClearCase, you had to hire someone as an administrator just to look after your version control. And the way it worked is if someone went away on holiday and they hadn't released the lock on the files they had checked out, no one else could work on them. Amazing. So ClearCase, IIS in Microsoft land. Mercury Interactive. Anyone remember Mercury Test Runner? One or two hands. This is one of these pointy, clicky, record a test, replay it type testing tools that were all the rage back in the sort of early mid 2000s to late 2000s. I presume people here have done web development. They might have used something called WebDriver or Selenium. Selenium, WebDriver, yeah, many, many more hands. Now, the reason that Selenium is called Selenium is because some of my colleagues in Thoughtworks India came up with the name Selenium because selenium is the cure for mercury poisoning. And that is the real reason. That's a true story, that. Yeah, so to move away. So how can we pull left? Shift left is all the rage. But this is building tooling back then to do that. Integration, yeah. Well, that was sort of. This is the WS star, the web service specification model. There's a specification for the specifications of the specifications. There's an ontology of specifications for integration using web services. It was nuts back then. It was absolutely just off the chart complicated. So you had SOAP, you had SOAP RPC, you had document-oriented SOAP, etc., etc., etc. You had lots of client libraries that you'd generate from WSDL files, and then you'd include those in your application. And then every time some XML changed, you had to redeploy, recompile. At the same time, lots of stuff that we take for granted was kind of controversial and or new. So, an example of some things here. Spring Framework, that came out at 2005, 6-ish, something like that. Tomcat was new. JUnit was fairly new. Certainly using it to write tests was fairly new. AWS was pretty new, sort of 2010-ish, 2011. Trunk-based development seems to have gone out of fashion, trunk-based development. This is where you always have you commit always to mainline, and your mainline is always deployable, and you hide, if you deploy and you don't want to turn a feature on, you use feature flags. And this is what you get if you put extreme programming into an AI image generator. Someone sitting on a cliff with a laptop. So extreme programming was new, or newish. This is from a talk I did with Daniel Tills North, this quote. Actually having a domain model was new. Now, domain-driven design, we talk about sociotechnical systems, we talk about domain-driven design and team topologies and organizing around our domains and Conway's law. Actually having a domain model at all was sort of new back 2005, 2010, that sort of time frame. Ints and strings were enough for everyone. Why would just use a string? Who needs an address or a user or a customer or an order or an order line? We just have a string and some ints and then a hash map, and that'll be fine. Maybe an array if you're lucky. And then you had obviously developers and operations. They were the best of friends. There was never any tension between developers and ops, never any tension at all. It wasn't like developers were optimized for change and getting stuff done, and operations optimized for not getting stuff done, safety, anti-risk, etc., etc. Rightly so at the time. This was hard. So it was a very different world, I guess, a very different place to the one we sort of find ourselves in now. But that's at a time, 2007, 2008 to 2012, it was sort of the right time, the right place to sort of, for the industry, I think, to take a bit of a step forward. And I'm not suggesting microservices are that step forward, but there was a whole bunch of patterns and practices that I'll talk about that together became this microservices style. It was this idea, we're crossing the Rubicon, alea acta est. The die is cast. We're going to move forwards for better or worse. So this is my version of where microservices came from. There's a whole bunch of people I want to call out because they're all very influential in this. Some of these you'll probably recognize, some of them you won't recognize. Some of the books you'll recognize, some you might not. So we've got Domain-Driven Design, the Blue Book, Eric Evans. Continuous Delivery by Jez Humble and David Farley about how we safely and sustainably deploy frequently into production. Evan Botcher, who was very influential in thinking about REST and SOA back in the day. Eric Dernenberg, my colleague, still colleague, is our European CTO, again very involved in the sort of SOA and sort of REST-y world. He's also the maintainer of OC Mock, if anyone's a Swift developer in the room, or has been an iOS or other Apple environment developer. Sam Newman wrote Building Microservices. Daniel Terhorst North, I worked a lot with him. He's behind behavior-driven development, but also was very influential. I'll come to him in the early thinking around REST and SOA and doing it in a different type of way. You've then got some lesser-known books, REST in Practice by my colleagues at the time, Jim Weber and Ian Robinson. The REST in Practice was about how you can use the infrastructure of the web or patterns and practices from web development to do integration internally, integration in our organization. So we didn't carry on reinventing the wheel, having that not invented here thing that most big organizations have, where they just want to build their own thing, right? This book was about why can't we just use the web? Why can't we just use REST, hypermedia? The standard verbs and so on. Very influential. Jim Weber also coined the term guerrilla SOA, which was a sort of precursor to microservices. Guerrilla in the sense of guerrilla warfare, as in trying to subvert big enterprise service-oriented architecture practices at the time. And then we've got, what else have we got? Enterprise integration patterns, the canonical work on messaging, release it, Mike Nygaard about designing for failure. So all these sort of things were sort of starting to emerge around 2007, 2010, 2012. There's one person here who I always have to call out. No one's ever heard of him, Chris Reed. He's a genius. He's got hair like a Lego man. He's amazing. And he's also one of the co-founders of the DevOps movement. There's Patrick Dubois and others, but he was one of the first people on the committee at DevOps Days, which is where the name DevOps came from, if you knew that. So a whole bunch of people, a lot of those people working in Thoughtworks, actually, in London at the time, and others who were friends of Thoughtworks, others who were sort of connected with us. We were sharing a lot of information, a lot of our practices via Martin Fowler's website and other places, writing books and so on. We've always been passionate about these sort of better practices being free, revolutionizing the IT industry, we always used to say, or still do. So we had all these people in place, and then a funny thing happened back in, this is about 2011, there was an architecture workshop at Castelbrando in northern Italy, and a whole bunch of people turned up there, and they included some of those people I talked about. You can't really see this, it's a terrible photo, I tried to edit it, this is the best I could get. But you've got Gregor Hope is there, you've got Udi de Haan is there, so Udi's from N-Service Bus fame, obviously big messaging people. Stefan Tilkoff was there, who's an SOA and REST person, etc., etc. And this guy was there as well, Martin Fowler. You might recognize Martin. Would you buy a used car from this man? And at that workshop, a funny thing happened. We were talking about, it was an unconference, so the themes emerge over time. And we seem to be talking a lot about big things. Why is it we have to maintain all these massive things? How patterns for maintenance? How do we make changes safely when you've got really big products? Monoliths wasn't a term that was coined at the time, but these really big products. Until on the last day, we sort of had this sort of realization, maybe we're solving the wrong problem. Maybe the problem is that these things are just too big. And if we broke them up, if we broke our products up into much smaller things, then we could scale our teams around them, we could maintain them more effectively, we could throw them away if we wanted, and then rewrite them. We could use different technologies depending on how appropriate they were to the task. And then I went back from this workshop to a client I was on and went, right, we're going to try this. And so we did. And then Martin turned up and made me write it all down. So I did this talk about this client I was at. It was building a loyalty management platform. And this is where the first set of things that I referred to as microservices practices came out. It was what I did last summer, how we designed and built a resource-oriented, event-driven system out of applications about 1,000 lines long. And we had a whole bunch of, I had a whole bunch of slides in here that talked about the practices we were using, which I think at the time were fairly new. So small with a single responsibility, each application only does one thing, small enough that you can throw them away. And they're small enough to fit in my head. I have to be able to understand everything this service does. Single responsibility principle, single reason to change. Located in different version control routes. So we used to have these big monorepos. The problem I found with monorepos back then is I'm stupid, frankly. And the problem with the monorepo is I see similarities and abstractions everywhere. There's a customer here, there's a customer over there. Ooh, they look a little bit the same. Let's smash them together. And suddenly you've got a giant customer object, right? You've got a God class where everything to do with customers in it. And every time you need to change anything to do with the customer, you have to do it there. And of course, if you're building separate services, then what that means is you have a shared library that you have to include at build time, and suddenly your build time coupled. Which means every time you have to rebuild the library, you have to redeploy your software, which sucks, right? So separate these things out into different version control routes. Have a separate version control repo for each thing. Containerless and behaved Unix services. So containers has got a different meaning now. Back then, when we were doing this, 2011, containers meant using something like Tomcat, right? Installing a WAR file into an application server, into a container, as opposed to Docker containers now, or other containers now. So what we were saying with this principle was, rather than do that, what we want to do is just run them as well-behaved Unix daemons. Right, just run them from the command line, java minus jar, and a jar file name. Everything's bundled into the same jar file. You've got an inline application server in the jar file, and you just run them like that. Again, seems like an obvious thing now, but this was really very new at the time. And then finally on this slide, provisioned automatically. So we were just starting to see Cloud Native come into effect. And the idea that we can define not just our containers, not just our sort of runtime environments as code, but also environments. So we had a system where you could, from the command line, spin up whole EC2 clusters and so on, and testing environments and these sorts of things. So these were the first set of principles that we talked about. Consistent and reinforcing practices, hexagonal business capabilities composed of microservices that you can rewrite rather than maintain, which form a distributed bounded context, deployed as containerless operating system services, standardized application protocols, etc., etc. And that was 2011. 2012, I did that talk, and 2011 was the project started that I did the talk about. Fortunately, the project was canned. Total disaster about 2 years later. Unfortunately, no one understood what the hell we were trying to do. Why don't you just build a big Spring application? And that's what they did. That was then canned 2 years after that, and they went back and built a microservices implementation, which makes me giggle. Anyway, I should point out, when I say this is my story about the origins of microservices, There's lots of other people who are involved. The people I mentioned who were adjacent to Thoughtworks, but specifically Stefan Tilkoff, rest his soul, he was talking about self-contained systems. He had a consultancy competitor of ours actually in Germany, in OQ, and he was talking about self-contained systems, which is sort of almost like a value stream slice through an application. Think of it that way. We had Adrian Cockcroft, who ex-Sun, and then he was at Netflix. He was the Netflix cloud architect, very well known, father, grumpy uncle of microservices as well. And he was talking about fine-grained service-oriented architecture. Big friend of Jim Weber, who was talking about guerrilla service-oriented architecture, so these threads start to come together. Daniel Tihos North, he talked about replaceable component architectures, again, a former colleague. And then Fred George, who had this concept of programmer anarchy and actually nano services, so lines of functional microservices that were no bigger than like 50 lines of code, 100 lines of code. So there's a bunch of people all converging on the same set of ideas back in 2012. And then Martin persuaded me to write this. The only way I don't know if you've come across there's a British science fiction author called Douglas Adams. He wrote The Hitchhiker's Guide to the Galaxy, very famous sort of humorous science fiction series of novels. And he had a lovely phrase, which is, I love a deadline. I love the sound it makes as it whooshes past. I'm very much similar when it comes to writing stuff down. Martin literally had to fly me to his house in Boston and put me up for a week. I went for a sleepover for a week in Martin Fowler's house. Thank you, Martin and Cindy, and we wrote this. And this, as I said, caused quite a stir at the time. So what I'm proposing to do now, because I've just talked a little bit about where this stuff came from, I'm proposing to talk a little bit about what's happened in the intervening 10 years. Some of the things I'm fascinated by, I can't cover all the developments in 11 years of software engineering since 2014 as it pertains to microservices. We'd be here till midnight tomorrow. So I'm not going to do that. But I will talk through some of the interesting sort of things that I've seen and how it compares to how we thought at the time. So componentization via services. We talked about what the definition of a component is. A component is a unit of software that is independently replaceable and upgradable. And then we went on to talk about microservices. One main reason for using services is that these components can be independently deployed, independent from the other services. All right. So the idea is if you componentize things around that process boundary, around a process boundary, right, rather than within the same process or using threads or whatever, then you can kind of more easily deploy these things. You can more easily scale these things than you can if everything's within the same process boundary, the same monolithic process boundary. So in some ways, what we were sort of thinking about was applying object orientation to systems architecture, if you like, to architecture in the large, and building distributed systems using principles of object-oriented programming, which is interesting because Alan Kay, back in some time ago, I couldn't find the actual date for this, but Alan Kay, obviously one of the fathers of object-oriented programming, he said, OOP to me means only messaging, local retention and protection, hiding of state process, and extreme late binding of all things. So you can kind of think of microservices, the way we were thinking of microservices is as a series of independent objects that are hiding state, keeping state internally, that are message passing, so passing decoupled via passing messages between them, and extremely late bound. So not bound at compile time or build time or deploy time, bound at runtime by passing messages. This is kind of the principles of OOP was really sort of what we were thinking about, although that's post hoc justification, I think. But it's also this, where some of this idea of things like different version control routes comes from. Separating these things out to make it, to almost insist that you have to late bind these things. They have to be bound by passing messages at runtime rather than compiling in libraries at build time. Now, there was a few things that I think we got wrong. I'll come to some of those. So one of the things that's tricky is this question of nouns v verbs, or entity services and the damage that entity services have done over the years. So by entity service, I mean like an order service or a user service or a customer service, a service named after, essentially, a noun or an entity in domain-driven design terms. There's a great piece on this, which I can't go into all of this, but there's a great piece on this which I recommend you read from Michael Nygaard when he talks about the entity service anti-pattern and the types of coupling that the entity service pattern introduces. Dan North, back in 2007, this has reared its head recently, wrote this brilliant blog post, a classic introduction to service-oriented architecture, where he describes how service-oriented architecture before microservices works in business terms. And in this, there's no mention really, there are passing references to entities, but really he's talking about verbs, he's talking about doing stuff, behavior, accomplishing tasks. As an example of that, I always used to, it was a thought experiment back in the day. We used to talk about, when we're thinking about designing services, think about going back to the 1950s before computers. If you were in a company in the 1950s, before you had access to computers, how would you book a holiday? You were sitting at your desk, you wanted to go away to Greece. I've been to my last 4 family holidays in Greece. Hi, thank you. I had to come to Greece again for 2 weeks. How would I book a holiday back in 1955? There's no intranet to go on. There's no email that I can use. What I would do is I would go to a cabinet. I'd pull out a request for a holiday, right? A request form, holiday request form, and I'd fill that in. And I'd probably put my name and the dates I wanted. I might put my phone number on it, etc. And then I'd put it into the internal post, into my outbox. And some person would turn up with a trolley later on. They'd pick that message up, the form up. They'd take it off to HR, the personnel department. Personnel department would pick that form up, and they look at it and go, it's a request for a holiday. And they'd make sure that I had all the business rules were followed, that I had enough holiday left to take, and all these sorts of things. They'd stamp it approved or denied, put it back in the post, and send it back. Asynchronous messaging, if you like. But the key thing about this, and how it relates to entities and behaviors, is that it wasn't. I wasn't like sending it to a holiday service. I was sending it to the personnel department, the personnel capability, and the personnel capability had a service essentially called holiday requests. Right? The behavior I want to accomplish is holiday request booking. It's not create booking or on a booking service. It's I want to request a holiday. And it's a very fine semantic change. But it's led over time to this sort of entity service anti-pattern. As I say, have a look at it. Mike Nygaard, he's brilliant on this. The other question that often comes up, and I still don't have an answer, is how big are microservices? I genuinely don't know. They should be the appropriate size, right? There was one definition early on, which was the size of my head. It was a bit of a joke about how much you can understand. Are they doing a single thing, single responsibility principle, and so on. But then, over time, you have to think about distributed transactions. If you've got 2 services participating in a distributed transaction, probably they're too small, you want to put them together, that's a bigger service. So there's all these different heuristics and rules around the size of these things, and I can't really give you a definitive answer still, unfortunately. Now, organized around business capabilities, I think this is something that we still haven't necessarily internalized. I don't think I have. What did I mean by business capability? I meant the what of our businesses, what our businesses do. Right? That's the definition of business capability, the people, processes, and tools that make up the what of our business. This, on the left-hand side, is from Microsoft Vision in 2009, which was an enterprise architecture tool they produced. And that's every company. That's the capabilities at top level of every single company in the world. And then if you're a retailer, you've got a different set of them, etc. If you've done to an insurer, to a bank, etc. And you break these things up into these different capabilities. And what we were saying with microservices is arrange your system boundaries around these capabilities because they're stable. They tend to form stable parts of your business. The boundaries don't change over time, and that's kind of what we want when we're building software. We want to build software around stable boundaries. They're cohesive, if you like, around a particular business concern. The personnel department is cohesive. I mean, it's very rare that I go into an organization and when I look at how IT is structured and how their systems are structured, that it matches how the business is structured. I think it's a bit of a sort of, finger in the air litmus test. Can your business folks look at IT and see the business reflected there? And if they can't, you're probably not organized around business capabilities in terms of the software or the people or the teams. There's another example from a loyalty management platform, the one from 2011. Of course, we then went on to talk about things like Conway's Law. This is Melvin Conway, by the way, if you've met Melvin. He's like laughing at us. You still haven't learned the lesson from 1960s. And this is one of the original diagrams, how we have cross-functional teams organized around these stable capabilities. Incidentally, I got this lovely, this has gone back to actually down north. There's a thing that's reared its head around SOA and around how we break things up. And there was this great thing on LinkedIn. Someone said, first, microservices, like any architecture, have pros and cons. Is there any competent software architect in my network who can explain to me, like I'm 5 years old, what the pros of having customers and orders in a separate database is? And you'll be hearing this name a lot. Daniel Terhorst North came in and took them to school, frankly, when they started talking about domain-driven design and how actually in one capability, a customer looks like one thing, but in a different capability, a different bounded context, a customer looks like something else. An order in a fulfillment system has an address and a time it's due to go out for delivery and all that sort of stuff. An order, when it's in being displayed on a website, has GIFs and pictures and videos and reviews and that sort of thing. They're different, and that's why orders can exist in different places or should exist in different places and not just in a single database. Anyway. Back to Melvin Conway. I got this email. I did a talk where I was like talking about Melvin being this Muppet, sitting on the balcony laughing at us, like in the Muppet Show, if you remember that. Maybe there's too young people in the room to remember the Muppet Show, don't know, but he's sitting there. And I got this email, I've recently come across your presentations, go faster than your competitors, and how I finally stopped worrying and learned to love Conway's Law. No, I'm not sitting on the balcony laughing. I'm sitting at my computer learning from you, blah, blah, blah. If you ever return to the Boston area, perhaps we can meet and break bread together. My best, Mel. Mel's a real person. Conway's Law is a real thing written by a real person who's still around. And many years later, I actually met Mel and his wife, Elizabeth. Decentralized data management. That's the next thing I'll mention. So in the original paper, the original definition, we talked about decentralized data management almost as in in two different types of ways. One in terms of how you coordinate transactions across them, but we also talked a lot about kind of polyglot uses of technology. Hey, wouldn't it be great if over here this service needed a graph database so you could use Neo4j, and then this service used Mongo, and that'd be fantastic, and that's in Go, and that's in Java, and this is in Haskell, and this is in TypeScript. The decentralized data management was focused more on that sort of polyglot aspect of using the right sort of tool for the job. And it didn't really make much sense. The other thing we didn't cover off in enough detail, I think, is how hard distributed transactions are. I mean, we did say they're notoriously difficult to implement, but we didn't go into a lot of detail. Now, this is an example from that 2012 project where we had these different capabilities, user management capabilities, fulfillment, and all of these are listening, they're subscribed to some things, they're producing events in other ways, et cetera, et cetera. So essentially you've got this sort of very, very eventually consistent system with events flowing backwards and forwards in different ways, which sounded like a great idea at the time, but then suddenly everyone had to become an expert on CAP theorem. Everyone had to become an expert on distributed system design and how to do choreography rather than orchestration and why distributed transactions were bad. Everyone had to sort of work out, okay, now we've got this system, is it consistent or available in the event of partitioning, which is Obviously, CAP theorem, you can have 2 out of the 3, consistency, availability, partitioning, and you generally want to have partitioning. So which of the other ones do you choose? So everyone suddenly had to become an expert on it, and it led to some quite entertaining publications. Beating the CAP theorem checklist. This is a whole checklist of things that you can go through which you might think you've beaten the CAP theorem, but you've forgotten to take into account X, Y, or Z. You can't beat the CAP theorem. Mike Nygaard, again, he did this brilliant talk actually at QCon, exploiting loopholes in CAP theorem. And then, of course, at the end of the talk, he said, of course, like it was a whole straw man, and the initial conditions aren't real-world ones. You can't beat CAP theorem. So that's obviously another kind of can't beat CAP theorem thing. And then Google, when they introduced Cloud Spanner, their global scale, consistently available database, they talked about how they were, quote, beating CAP theorem because they were consistent and available at global scale. What they failed to mention is the way they did that was 2 things. They bought all the atomic clocks, synced them up via GPS globally. All right. So the problem with essentially distribution and consistency is clock time. You can't, is this server the same clock time as this, same wall time as this? All right. So they bought all the atomic clocks to sort that out. Still, they only have a delta. They can only operate within a delta. And then at the end of the talk, they said, oh, and actually, we're not really CP because we've just got very good networks that never fail. Of course, in the real world, our networks fail, right? If you Google, maybe they don't. But suddenly, everyone had to understand how to do distributed system design. And it's hard. And this is why one of my pieces of advice over the years has been, in terms of size, try and avoid distributed transactions in distributed systems. Try and avoid having 2 services having to coordinate a single transaction between them because it's really difficult. You end up needing either to write your own Raft or Paxos implementations. You need to use lots of tooling. It's much easier just to make the service bigger and just do it in one place. So the next thing was more, it's all trendy now, Sociotechnical. This is one of the more socio-technical aspects of microservices. Products over projects. The interesting thing I think with this is, if not the first, we were pretty early on in talking about the idea of long-lived product teams. Of course, we were influenced by Build It, Run It from Amazon, AWS, they've been doing it for a long time. But this idea of, in general, it's better to have longer-lived product teams versus shorter-lived project teams who disappear after the project's finished. That's what we sort of wrote about back in 2014. And then my then colleague, Tyrion Naranian, he wrote this up in detail in this article, Products Over Projects. And the point he makes in this is that this is actually about funding and how you fund work. And if you like, business capabilities are about the sort of the long-lived structure, the what of your business. But how you structure your product teams versus project teams are a financial construct that enables fast flow. It enables us to get more work done more effectively. Because people build context, we're not having to constantly shift people around and so on. And since then, of course, this has been, I guess many organizations have adopted this. We've got, Netflix is a classic example. They rewrote their API about 5 times. Netflix API, they went from Java to Scala, back to Python to up and down and round and left and right, and etc. But then we've got lots of work around things like team topologies, a ubiquitous language about how we structure our teams, how we structure our product teams, different types of product teams, how we manage cognitive load, and then dynamic reteaming by Heidi Hefland, which is like the sort of the missing bit. And that's how we move people around between teams without causing too much disruption. Right? Because we've all faced the situation where you've got a team of 10 people, and at one point there's enough work for 10, but maybe the next time there's only enough work for 4 or 5 people. How do we move people around, flex our teams to avoid that? We've then got decentralized governance. So decentralized governance, again, we talked more about, hey, you can choose whatever technology you want. You can choose Node.js if you like, or you can choose C++, just go for it. And then we went on to say, of course, just because you can do something doesn't mean you should. I think this probably turned out to be a terrible idea. Actually, I think this is one of the things that really hasn't stood the test of time. And what we've ended up doing is focusing more on consistency. Let's choose a couple of things. Let's choose a couple of ways of implementing stuff, a couple of patterns, and do that, rather than just have a free-for-all. Everyone can use whatever language or database they like, which was happening for about 3 or 4 years. The other thing we were talking about with decentralized governance is how do you make decisions locally? If you've got these autonomous teams organized around business capabilities, how do we enable those teams to make effective, safe decisions without having to always ask someone else, go up in a hierarchy or whatever, or ask the big boss? There's a great book that's been written recently. I heartily recommend, if you're in a management position or leadership position, or anyone else actually, it's a good read, it's a short read. Take a look at this, Turn the Ship Around, by L. David Marquette. L. David Marquette, he's a former NATO submarine commander. Sorry, yes, American nuclear submarine commander. And he talks about how he took the worst performing submarine in the US Pacific Fleet and turned it into the best performing submarine. And the techniques he used, but he's got a lovely phrase, which is, don't move information to authority, move authority to the information. Enable the people who've got the most information, who are closer to the work, enable them to make safe decisions. And how you do that is by putting different frameworks in place. But that's really what we were talking about. How do we enable our teams to be autonomous enough such that they can make these decisions on their own? And of course, since then, there's been a whole bunch of work around this. I saw someone taking a photo, I'm not sure if you got that. Probably. There's been a whole bunch of other stuff published, Sociotechnical systems. Facilitating software architecture is just out by my colleague Andrew Harmel-Law. That's brilliant. That's a brilliant book. It's about how you move architecture decisions down to people who are doing the work again. So enable them to do that safely by consulting everyone who's got I guess, skin in the game, but then them making the decision. Software architect elevated Gregor Hope. Team topologies building evolutionary architectures. Another thing I talked about back in 2012 is this tip I had, which is build tooling to enable our teams to go faster. Right? One aspect of autonomy is teams building tooling to allow them to repeatedly do stuff. So we have this tip, which is make it easy to do the right thing and hard to do the wrong thing. Use tooling and architectural tests to make complex tasks simple. And in that case, we've got. I talked this morning about platforms and the problem with platforms, but platforms and platform engineering, product platform engineering teams are, I guess, the sort of end result of that sort of thinking, right? Can we start building platforms that enable us to go faster? Provide tooling to the rest of the organization to enable fast flow. A platform team is a success when the rest of the organization goes faster. That's their success criteria, right? Other metrics apply for other teams, whether that's reducing lead time to value or whatever it is. But it's the derivative of reducing lead time to value, which is what a platform team should focus on. And that's making the other teams reduce their lead time to value by providing self-service tools. We then talked about smart endpoints and dumb pipes. Where am I? Yeah, we then talked about smart endpoints and dumb pipes. So we had this massive web service topology sort of thing. There's a great talk back in a long time ago now. I think this was like 2008. Talk by Leonard Richardson about using REST and RESTful practices internally in our own organizations. So this is a lot of where REST in practice came from. And this is where we were thinking about with smart endpoints and dumb pipes. You don't need big bits of software to coordinate things for you, right? You just build these services, and the services have state machines that are able to react to the smarts that react to receiving messages and then produce messages. You don't have some big machine in the middle that has all the translations and all the business logic and all the rules. Those are in the services themselves. And he talks about the maturity model here. The level 3 maturity model is divide and conquer using URIs, reduce complexity using HTTP, and describe special behavior using hypermedia. We've sort of decided not to do any of that now, right? Like, we'll just use Kafka. Or RabbitMQ. We'll just go, hey, Kafka. Kafka solves all our problems. Except, does it? It solves all the architect's problems, certainly. Again, a slide from way back. From an architect's perspective, messaging is loosely coupled, asynchronous, all these great properties, but from the developer's perspective, it's really, really, really hard. Right? It's really hard to grok how messaging works when you first start using messaging, when you first start building distributed systems. This is a quote from an architect I was working with Sam Newman on back in 2012 when we were describing how this distributed system was going to work. He said, when you or Sam are in the room, we understand it. But as soon as you leave the room, we've got no idea what you were talking about. If you make a shift from building monolithic applications to building distributed systems, it is a big shift. It's a big cognitive shift. So smart endpoints and dumb pipes. Couldn't you just use RabbitMQ? Said no one ever. And then, hey, gRPC made a comeback, or RPC made a comeback. We moved away from remote procedure calling, right? Because it was really, really, it sucked, right? SOAP RPC sucked. Pretending there was no network in the way sucked. But turns out it's fine if you Google. We can just do it if you Google, because it just works. This is Martin's law of remoting, don't. And then we moved on further, and we've got lambdas, and we've got things like SNS and SQS and blah, blah, blah. So stored procedures in the cloud. Stefan Tilkoff calls lambdas. I love that description. We've invented stored procedures in the cloud. But of course, with great integration power comes the high probability of making a massive mess. And we're seeing more and more and more now. We call this pattern lambda pinball on the tech radar, Thoughtworks Technology Radar. This is where you just got 200 lambda functions. They're not separated out in domains. They're haphazardly in different version control routes. And there's just messages bouncing from endpoint to endpoint, and no one knows what the hell's going on. And it's impossible to know what's going on. So if you need to add a new thing, you don't change an old thing, you just add another one, right? So you've now got 151 lambdas, 10 of which are probably doing the same thing. High probability of making a right old mess, lambda pinball. So there's a few questions I had. There was a bunch of stuff we were doing back in 2009, 10, 11, 12, and a bit further on, that sort of disappeared. Micro formats, remember those? Anyone remember those? This is where we had a standard way of describing things on the web, or in messaging, or in RESTful resources. You had an address card, right? Looked like the same. You had a micro format for it. You had a micro format for calendar entries. Standardized ways of describing the contents of messages that we'd be passing around, or resources that would be returned from servers. I think everyone just makes it all up now. Same with domain and application protocols. They're standardized ways of communicating between services that everyone knows how it's going to work, maybe using Atom or OData or some other tool like that, some other protocol like that. They've disappeared. And then, who can I blame for JSON? Seriously, who can I blame for JSON? It's a terrible mechanism. It's a serialization mechanism for JavaScript, for a programming language. Why did we decide to use it as a messaging format? Anyway. Then we've got evolutionary design. Evolutionary design, that was that next one of the principles. So I think about this as the ability to make small decisions and keep our options open for the future. Like evolving our system rather than trying to decide up front to place all our bets on a particular solution, evolving the system slowly over a period of time, trying to make the best decisions as we can, keeping our options open. Martin Fowler had this quote, I think it was Martin, he says it's Ralph Johnson. Software architecture is those decisions which are both important and hard to change. And in building evolutionary architectures, they sort of talk quite a lot about how the fact that these days there's a lot of decisions that have become easier to change. And we can actually use a whole bunch of tooling to enable that, to enable us to make those decisions in a safer way. So for example, by writing fitness functions around our architecture tests, by writing fitness functions, tests that we run in a part of our build pipelines that we can execute every time we commit, that will ensure that we're not, violating certain architecture principles around modularity, et cetera, et cetera. So, it's interesting because software architecture, decisions that are both important and hard to change, but over time, some of these decisions have become a lot easier and we've developed tooling to allow us to do that. Infrastructure as code is a good example of that. So with infrastructure as code, that's taken a lot of the architectural decisions that were hard and made it easy, because we can define all that stuff in code and rerun the code. It used to be really hard to say, can I have a new data center in the US now, please? Now I can make a change to a line of code and stand up my entire infrastructure in the US if I need to. Not a single line of code, more than one, clearly. So things have evolved in the intervening years, and things that were very difficult to change are now much, much easier. So that's just a taster of some of these characteristics and some of the interesting things I think have happened over time. So the evolution of Kafka, obviously the evolution of integration is interesting. The evolution of infrastructure as code is interesting. The evolution of evolution is interesting. Product over projects now, we've evolved into socio-technical systems. That's what we talk about these days, building socio-technical systems. All these things sort of had their roots really in a big change that happened 2010. And I'm not saying that was to do with me. I'm saying there was about 15 or 20 or maybe 50 people around the world who all converged on the same ideas at the same time, and it all led to this explosion in the stuff we see and the stuff we see now. So there were some unexpected side effects. I've got a minute or so left, I believe. Microservices moves the accidental complexity to the infrastructure, Martin said. It's true, and this is what Amazon Web Services used to refer to as undifferentiated heavy lifting. All the stuff that they didn't want their teams to do, and it's why they created AWS, right? Moving all of that stuff out of their teams. And we've sort of continued to evolve that by taking a bunch of other stuff away from our teams to have to think about. So as an example of that, we've started to take things like reliability concerns, observability concerns out of our teams. I would argue that these are functional requirements. You can't go live unless you're not functional unless you're reliable and observable. But by having things like, using things like service meshes to provide all this, and sidecars having things like observability tooling that are essentially built into this toolkit, we've taken the essential complexity or some of it out of our applications and moved it into the infrastructure as well. I mean, developer experience platforms are, I guess, another example of that. We haven't, this is things like Backstage from Spotify, these tools that allow us to very quickly self-service stand up the sort of specific tools our teams need and define them ourselves. I guess data mesh. Data mesh is the sort of the evolution of this in the data space. So having data products as part of your capabilities, which are providing metadata and discoverability for the data you can offer in terms of analytics and reporting. What I wish we'd done differently? Well, this is a great quote. Any sufficiently complicated C or Fortran program contains an ad hoc, informally specified, bug-ridden, slow implementation of half of common Lisp. This was Greenspun's 10th law. What he's trying to say is, as you get more complicated C or Fortran programs, you end up with something that looks a bit like a crappy implementation of Lisp. And Daniel Tuhorst North, he sort of took that quote and he changed a few words. Any sufficiently complicated microservices implementation contains an ad hoc, informally specified, bug-ridden and slow implementation of half of Erlang. So maybe we should have just forgotten the whole thing and used Erlang. Other stuff that I'm a bit unsure of still. Infrastructure as code is still a mess. Is it infrastructure as code, from code, as data? Who knows? It's still a mess. It's still in YAML and JSON, and it's a nightmare. We've still got single integration testing environments on the radar. We haven't learned this lesson that we can be cloud native and spin stuff up. The name, I'd probably change the name. Microservices talks about the size, not about really the characteristics. Maybe it's more like extreme architecture rather than microservices, because it's a whole bunch of stuff around it that's important as well as the size. What did we miss? Well, we didn't talk about cloud native at all. We completely missed that one. We talked a little bit about deploying to the cloud and how you deploy and continuous deployment and that. We didn't really talk about continuous delivery as a first-class concern. And we didn't stress the importance of being this tall either. So, the idea that you have to be this tall to get on a roller coaster. Like, you have to be this tall to start building distributed systems, essentially. It's not a 101 thing to do. And I still recommend starting with modular monoliths. Finally, we didn't talk enough about deployability. And this is the thing I see that's the biggest problem with microservice implementations, is the big ball of mud applied to microservices. So distributed monoliths, having to deploy everything all at once. Wish we talked a lot more about that. Are they the future? Well, we asked that question at the end of the paper we wrote. So far, we've seen enough that it's a worthwhile road to tread. We can't be sure of where we'll end up, blah, blah, blah. But then in Accelerate, State of DevOps, they talk about the effect of loosely coupled architectures on software delivery performance, etc., and they talk about substantial increases in performance. Are they the future? No. You'd be pleased to know Gen AI is the future, the robots are coming, so that's all good. And I'm going to finish now, a couple of minutes over. Thank you very much indeed.